end of my Portuguese, so I'm afraid the rest will be done in English. So welcome to the community overview and reference architecture portion. We will be talking about Ceph in general. Will be two presenters. We'll split the time. Myself, my name is Patrick McGarry. I'm from Red Hat. I'm the Global Director of Community for Ceph, who here is familiar with Ceph, already knows what it is, maybe heard Christians talk a little bit, Kiko's talk? Okay, cool. So at least there's a few. I will do a brief overview of what Ceph is, but if you want to know more details, come stop by the Ceph booth and we'll fill you in. Dan, you want to introduce yourself later, or do you want me to do it now? All right. Dan will introduce himself. Okay, we've only got 50 minutes. Yeah. So we'll get started. So Ceph, what is it? Ceph is software-defined storage. What does that mean? It means we can take commodity hardware, whatever you've got laying around the office, all the way up to crazy amounts of money in your infrastructure. You install Linux, you install Ceph, you now have all of that hardware put together in a single storage appliance, if you want to think about it that way. Ceph differs from many of the different offerings on the market in that at the very lowest level, it is an object store, which means you don't have all the POSIX semantics that go along with many of your filers and other things like that. So at the very lowest level, you can see down here is Rados. That is written for Ceph. It is a piece of Ceph. You won't find it in anyone else's technology, but that handles the data replication and data placement within your cluster. So it knows what's going on and where to put your data. Above that, another piece of uniqueness that Ceph has is that it offers the ability for you to interface with this object store via an object, block, or file interface. Or if you're really adventurous, you can use the Librados library, which has bindings for all kinds of languages, Perl, Python, PHP, et cetera, and roll your own. So a multitude of different ways to access your Ceph cluster. But basically what this means is you take a whole bunch of hardware, you put it together, and then you can use it for a number of different applications. The most popular of which right now is the OpenStack application. So we have a very tight integration with OpenStack. Our block device will plug in directly with Cinder and Glance. Our object file, our object interface can talk either Amazon S3 or OpenStack Swift and can just be a drop-in replacement for object storage in your OpenStack cluster. And we now also have an interface for CephFS to interact directly with Manila. So all of your object storage needs, object block and file within OpenStack, got that covered. Ceph really excels at large deployments and cloud applications specifically. So we also work with things like CloudStack and Ganeti and OpenNebula and all kinds of the other cloud platforms out there. But if you're interested in having just standalone storage, Ceph can do that too. Now, underneath all of this, what does it actually look like? Kind of like this. So down here on the bottom, each of these you can think of them as an individual node in your storage cluster. So you have an object storage daemon, you have a monitor. Those are kind of the two main pieces. The OSDs, so what it looks like is you'll have a disk. On top of that disk right now sits a file system like XFS, X4, whatever it is. And then on top of that, you've got the software that's running your object storage daemon for Ceph. It's where all of kind of the smarts live within the cluster. They talk to each other. They kind of take care of self-management, self-healing, self-replication, all of that stuff. So early on, when we were first explaining Ceph to storage admins, I think the most excited I would see people get was when they realized that Ceph did a lot of the day-to-day heavy lifting for them. In days of yore, you might see people who said, okay, every 500 terabytes I need a new storage admin, or whatever their particular metric might be. With Ceph, we have guys that are managing 5, 10, 12, 15 petabytes in their spare time while they do other jobs. So it's really nice. It makes a lot of your life as a storage admin way easier. If you'd like to know more of the nitty-gritty, like I said, stop by the Ceph booth. We'll fill you in. Most of this, of my portion anyway, is going to be talking about the things that are happening in the Ceph community. If you missed Kiko's talk an hour ago or so, I would highly recommend that. A, it's in Portuguese, so it's much better. And B, it was also a really good rundown of how Ceph works, how to get going with it, and what you can use it for. So, a little bit about the history of Ceph. Ceph was, the first commit was done in 2004. So we have been around for a while. It was originally written as part of a Department of Energy grant. We call them the Tri-Labs. So Lawrence Livermore, Ornell, and I always forget the last one, Sandia. So the national laboratories in the United States got together, and they asked Sage, our founder, to basically write a system that had the ability to do horizontally scalable metadata. So that's kind of where Ceph started, as a distributed file system. Fast forward to 2007, when he got done with his doctoral thesis. Then Sage, who had also previously founded DreamHost, which is an American hosting company, he went and took it back into DreamHost, and they started incubating and working on it, and starting to put it to their own uses. Because it was open source, however, and the source code was floating around out there, suddenly other people had started to come to them and say, hey, can you help us with this? We want to use it too. So in 2012, they decided that it was time to make a real big boy company. And that's when Inktank was founded and spun out of DreamHost to help people kind of commercialize and deploy Ceph. We did that for a couple of years, and then in 2014, we were acquired by Red Hat. So that's kind of the quick and dirty history of Ceph. The graph there is just the number of authors that were committing to Ceph at any given time. So definitely had some nice growth, and in the 2 years since being acquired by Red Hat, that growth has absolutely continued. So it's been a really exciting time for us working on Ceph. So why Ceph? What is it? What's fun? What's interesting? Why do we care? Ceph is open source, but beyond being open source, as most of you I'm sure know, there is a wide range of licenses and ways to call yourself open source. Ceph is very much copyleft. We are an LGPL license with a deliberately fragmented copyright. So that means no copyright assignments, and every single contributor owns their own contributions to Ceph. So I always get really excited about this, because especially in a period where we got acquired by a big company like Red Hat, it means if Red Hat wants to change the license, every single person that has ever committed to Ceph would have to agree and sign off and say, yes, you can do this horrible, evil thing, go for it. So the nice thing is Ceph will always be owned by the community, which is important to myself and Sage, and we really kind of try to use that as a guiding principle when making decisions. As I mentioned, is software-defined storage. A lot of people, the very first question, or I guess the second question that they ask me after they figure out what Ceph actually is and what it does is, well, is it enterprise grade? Can I put this into production? Can I put the data that I really care about onto my cluster? And rather than just tell them yes and ask them to trust me, which immediately makes people distrust you, I usually point at all of the people that are doing very interesting and exciting things with Ceph. You see deployments and work being done and long-term strategic bets being placed on Ceph by all kinds of people. The Ceph community, as you'll see in a little bit, is made up of a lot of individuals who decided that this was exciting, and they wanted to stop enabling people like NetApp and EMC and big companies that we pay too much money to, and really do the open source thing. But you also see people, Intel and Fujitsu and SanDisk and Samsung and all kinds of people in the business world, as well as the academic space. The labs that I mentioned, or CERN is actually one of our largest users. So it's really nice to see that, yes, you can do real things with Ceph and you can trust your data. I guess the next question after that is, well, how big can I get? And the answer is, I haven't really seen anybody hit a limit yet. The largest production deployment that I'm aware of is 40 petabytes and growing strong. So definitely a lot of data being pushed into Ceph clusters. The average size that I see in big production deployments is anywhere from about 3 to 8 petabytes, which is still a pretty big chunk. We have a couple of ambitious users that are anticipating that they will hit hundreds of petabytes by the end of next year, but we'll just have to wait and see if they get there. Unified storage. As I mentioned, this is a really great feature of Ceph, where you have a single pool of hardware, and now that doesn't mean it's all the same either. You can have some spinning Rust, you can have some really awesome hot NVMe drives, some SSDs, and you can kind of segment which pieces of your Ceph cluster are using which hardware, which means if you have a very performance-sensitive part of your storage that needs to sit on Ceph, you can assign them the really hot, fast drives. And if you've got some cold data archival, you can put it on the platters. And it's really nice that you can have a single-purpose cluster that you can kind of performance tune across a wide array of use cases. And then, as I mentioned, we have all kinds of different integrations that people are using and taking advantage of. So it's really nice that for a relatively young data storage solution, only been around for a little over 10 years, there are a lot of really cool things that are happening in our community. Ceph Days. This is another staple of our community. In addition to speaking at events like this, we also make an effort to get around the globe and host day-long events hosted by and for our community. What this means is it's a day-long event where typically we will go into somewhere. Intel has hosted a few, as Dan might mention in his portion here. But a company will bring us in and say, this is all for the community. There will be no commercials, no advertisements, no sales pitches. It's just real people talking about what real things they're doing with Ceph. And we've hosted these all over the world. And typically all it takes is for someone to raise their hand and say, I'd like to host one. And then we bring in speakers and we host a day, we have lunch, we make a whole day of it. The upcoming one is going to be in the Asia Pacific region. We'll be doing five cities in 2 weeks, so that's pretty exciting for us. And then the beginning of next year, we'll be back in the Americas. So definitely keep an eye out for one coming to a city near you. Metrics. Another thing that we felt was very important was that everything we do in the Ceph community needs to be very much in the open. And this includes kind of activity metrics. What's going on in the community, who's doing what. So all of the metrics that we gather and collect are posted at metrics.ceph.com. This includes, IRC traffic, this includes mailing list traffic, code commits. Every release that we do, our user committee actually gets together and says, okay, who are the committers that committed to this release? Who are the organizations that committed to this release, and just kind of showing who's busy in the Ceph community, which is really fun for us. But we're actually looking at taking this a step further in the near future. We're going to be launching a tool called Ceph Brag, which is going to be a public performance repository. So we will have the ability to collect data sets from people. Anyone that wants to run a performance data set, there's a tool called CBT, the Ceph benchmarking tool, that kind of gives us an apples-to-apples comparison over anybody's Ceph cluster. So anybody that wants to run performance tests and then share it with the community, that's awesome. It shows, allows the community to kind of say, hey, I've got 1.4 million IOPS on my cluster, and it only cost me, $50K or whatever. And now on the flip side of that, being on metrics.ceph.com, it also means that our community can go and say, all right, I have an object-heavy workload, and I would like to find out how I can get the most performance out of that. And you can go see, okay, all of these people have object workloads, and this is what they've done as far as hardware, networking, performance tuning, etc. So it'll be a nice guide for the people that want to either up their Ceph game or just get into it anew. Governance. As I mentioned, there's a lot of people that are playing in the Ceph community right now, and so we felt it was important that everyone had a voice. The Ceph community is very much inclusionary. We're very welcoming, so we work very hard to make sure that everyone that participates or wants to participate is able to do so very easily. Now that meant that with companies wanting to make large, long-term strategic bets on Ceph, we wanted to make sure that they had a place at the table. They wanted to have the ability to kind of raise their concerns, but also coordinate with each other. So we didn't have 8 companies all trying to write the same erasure coding mechanism. So kind of work amongst ourselves a little bit better. So as you can say, Sage, our founder, kind of sits there and says, this is what's happening as far as the technical direction of Ceph. This board is simply an advisory board used for communication and coordination. They don't actually control the technical roadmap. That is all your typical open source meritocracy. And then we have 2 folks over here, which is hard to see in the yellow. Vito Den Hollander is the chair of our user committee. So basically, as an individual, if you have something to say or want to weigh in on what's going on in the world, you can just tell Vito, like, hey, I have a problem, here's what it is, go take it to the board. So he's there to represent the individual. And then Dan Vanderster from CERN represents kind of the academic world in Ceph. We felt it was very important from our academic roots to make sure that their use cases were represented. And then the other folks here, as of about October last year, were some of our largest contributors, and we wanted to make sure that they had a voice. Ceph Tech Talks. Speaking of things that can be done remotely, every month we typically have a Ceph Tech Talk that is hosted virtually. You can dial in, listen to somebody talk about a Ceph topic for an hour, and then there's some interactive Q&A. They are all posted on our website. I believe, yes, here, Ceph Tech Talks. There are URLs to all of the YouTube videos. We record them and post them up for people to consume later. There have been some great talks by our core devs about the S3 Rados Gateway, the block device, the file system, the underlying thing called Rados that I mentioned, as well as some folks talking about what they're doing with integrations and other things like that. So it's usually a great hour of somebody talking about something really cool that's going on with Ceph. They're on the 4th Thursday of the month, typically around 1 p.m. Eastern Time. Ceph Developer Monthly. So it used to be that we would release a new version of Ceph every quarter, every 3 months. And after that release happened, we would all sit down on a Blue Jeans conference and talk about what's going into the next release. These, as we started to get more and more contributors, started turning into 8 and 10 hour slogs, and Sage and I just couldn't physically handle it anymore. So we decided that it was better to kind of spread this out a little bit more. So every month now, the first Wednesday of the month, we sit down for a couple hours, and we alternate between time zone friendly areas. We have 1 month we'll be in a US, Western Europe friendly, and then 1 month we'll be in more of a Asia Pacific friendly time zone. And it's just the developers getting together to talk about what's happening in Ceph, where's the roadmap headed, and what kind of problems are we looking at, integrating 2 different pieces of development, just what's going on in the development world. So I always recommend anyone that's interested in Ceph at a deep level, come just observe. Just watch and listen to what's going on. Anyone that has been interested in being a Ceph developer that has come to a couple of these usually ends up at presenting at the next one about what they're working on. So, great way to get involved. Ceph.com, right now it is probably the very best of 1994 web technology. Ceph.com is aging a little bit, but within the next month or so there will be a new one. If you'd like to see the design, it's at new.ceph.com. But it does have some really great tools. Our documentation, I'm really proud of. We had a guy who, at Inktank, would look at code commits and turn code commits into readable, usable documentation. It was something akin to black magic. Very impressive. But the docs are quite good. We also have links to our wiki and some other community resources there. So definitely take a look at ceph.com. It's a good place to start. I also like to just mention this. If you're interested in playing with Ceph at home, keep an eye out on our social media and website and things like that. I'll be building a Ceph demo pod out of, I'm using the Minnow boards, but you'll be able to use pretty much any system on a chip board and build your own Ceph cluster to play with and have a toy in your basement. There will also be some classes coming from the edX platform in a partnership with the Linux Foundation. Just wanted to mention that. And if you're really excited about Ceph, August 23rd through the 25th of next year, that's 2017, we'll be hosting Cephalicon, our very first Ceph-only convention, and we'll be in Boston next year. So that's something we're pretty excited about. The last piece is, as I mentioned, we started with a scalable metadata server as where we started, and we're finally back to that. So the OpenStack world kind of took us on a side journey where our object and block use cases got a lot of attention, and CephOS was nearly awesome. But now with the Joule release, we are excited to say that the file system is also awesome. So please get in there, use it, let us know what you think. So that's my portion of the talk. If you have any questions, I'd be happy to answer them now. If you would prefer to ask your question in Portuguese, I can force Leo to translate. All right, stunned silence, that's my favorite. All right, so the next portion here, I'll have Dan from Intel. He's going to talk about some reference architectures, and Dan, I'll let you introduce yourself.
This advances slides and goes back. Okay, good. You can hear me? Okay, and I'm going to stand down here because I will fall if I stand up there. And I'll introduce myself in a minute. I'm just curious one thing. ¿Quién aquí viene de un país donde se habla español? Nadie. Casi nadie. Okay, so you're all from Brazil. Just about all from Brazil. Okay, great. Like Patrick, my apologies for English. My Portuguese is not good, but I will try to speak slowly, and I appreciate you being here to hear this. So I work with, and I will walk around a little bit. Sorry for the video. Well, you can earn your money. So I am, or maybe you're volunteering, which I owe you coffee. So I work at Intel, and I'm based in Minnesota, in North America, but I'm here as a community member, right? As Patrick said, there are a lot of individual contributors, there are a lot of public company contributors, and there are a lot of industry contributors to Ceph. So Intel has Ceph developers, and we have worked for a long time contributing code to Ceph. Our main interest is in Ceph performance, right? So we usually work in Ceph performance, but they're very, very proud of how Ceph has come in 10 years. They're really, really great. And at Intel, I work on Ceph. I work to help end customers use Ceph. I help partners, OEM partners, ISV customers. So I'm going to tell you a little bit about some of the tools we have. Here's the agenda. And mostly today, I want to talk to you about reference architectures. So reference architectures or recipes are really good, and we've made a lot of progress in this last year. Many companies have, including Red Hat, including Intel, on reference architectures. So I'm going to show you some of the public reference architectures that exist. And the reason that reference architectures are really good is because they show you how to put together a Ceph cluster or how to buy a Ceph cluster, but they also show you what kind of performance to expect. So one of the big questions is, you know, if I go home tonight and create a Ceph cluster, what kind of performance will I see? And these reference architectures can help you understand the kind of performance you'll see. I do run a Ceph cluster on my laptop. It does not perform very well, but that is possible, and these are more enterprise kind of systems. So what are reference architectures? And I'll look along with you here at the slide, but usually reference architectures, and what I will show you, start with use cases. Yep. What kind of I/O use case do you have? Do you have a very archive, backup, slow, inexpensive need, or do you want to have a very high performance, lots of IOPS? And then after you look at the use case, then we look at configurations, as I said. And we also, you will see as you look at some of the documents later, if you are interested, you'll see we also have some replication performance, some erasure performance, erasure code performance, and then you can take a look at the different characteristics. So here is my tour, right? This is mostly pictures. Here is my tour journey of reference architectures. And here we have 1, 2, 3, 4, 5, so 9, right? And I'll mention just a few of them. So these first 3, these are all papers. These are all publicly available. So if you do a search, you can easily find all of these on either the Red Hat or the QCT, Quanta Cloud Technologies, or this is Supermicro. But all of these tell you, and especially these last 2, this QCT and this Supermicro reference architecture actually look at clusters, Ceph clusters that are built on QCT systems, and they have different combinations, or Ceph clusters that are built on Supermicro systems, and then along with the different configurations, they have different performance. So they run FIO tests on sequential and random and different mixes of workloads, and you can actually see this document here is maybe 20 pages. They're in English. This one here is about 40 pages, and they have a lot of good performance information about Ceph and configurations. And then the Intel Red Hat document is shorter, and this does not have performance information, but this document has the rules for Intel processors and Intel SSD for different combinations of Ceph. In the middle, these I do believe are all slides, but they're also reference architectures. So this one is a presentation that Intel did on all NVMe Ceph cluster. So this is a lot of IOPS that are generated and a lot of performance data. And also this presentation has all the Ceph tuning data and the CBT YAML file. I mean, I know not many of you use Ceph, and for anyone use CBT, the Ceph benchmarking tool? Probably not, but it's a very easy way to generate Ceph and to test it. This is a Red Hat presentation at the same database conference, and so this compares MySQL running on a private cloud versus MySQL running on a public cloud provider. And then this is a presentation that was done, the SanDisk presentation at the last Ceph Days in, last Ceph Days in Switzerland in June. And so it is a reference architecture based around SanDisk SSD. Here's a SUSE. SUSE also, I mean, there are several ISVs that offer commercial support for Ceph. Obviously, Red Hat is one of them. SUSE is another. There are many others. And so this is a SUSE reference architecture with HPE. This is another Intel white paper that is available from Intel on many different configurations, including one large configuration at Yahoo. And then this is a Samsung reference architecture that was just published with Red Hat. So you have a lot of examples of how to put together Ceph systems and what kind of performance you can expect. And this is really good, and this has all happened in the last year. So I'm just going to show you how some of these are organized. So in the QCT and also the Supermicro reference architecture, both of them have this kind of table. Table number 1, and it's very high level, no performance here. But what Red Hat decided to do, and there's a person that manages the group at Red Hat that produces these, they decided that at a meta level you could segment performance into IOPS, so configuration where you mostly wanted IOPS, or configurations down at the bottom, the third layer there, configurations where you mostly want capacity, right? So you you don't care about performance, and maybe you want to have a very inexpensive archive or backup system. And then in the middle, right, you kind of have a middle of the road. You care about IOPS some, you care about throughput some, but you don't want to spend, you don't want to have an all NVMe cluster. So those are the three kinds of architectures that in general are described in the reference architectures. And then this is an example from the Supermicro, and you can't see it very well, but then they start to have tables of configurations also at different size. So horizontally, we still have IOPS and throughput and capacity, but then on a vertical axis, we also have different configurations based on size. And in the Intel, it's interesting. So in the Intel white paper that I showed you, we also have a sub-segment, right, for SSDs. So we sort of have a good, better, best. I know this is almost impossible to see the chart, but here we have the different ways you can use SSDs. So you can use SSD as a journal, as a write journal for Ceph, or you can use an all SSD cluster for Ceph, but with SATA SSDs as the main storage and NVMe SSD for the write journal, or you can use an all PCIe NVMe SSD Ceph cluster. So the Intel paper talks about that. And then in each paper, or most of the papers, including the Intel one, but also the others, then you have tables. There's a little bigger version of table number 1, and those 3 different classes, right, IOPS, throughput, and capacity, but then we also have some example uses, some example use cases. Then again, we have sizing and what typically you see, right, how many disks, how many SSD, and form factors. And then the reference architectures start to get into the actual configurations, right, and what kind of processors, what kind of SSD, and what kind of performance will you see from those. So it's really it's a great way to know what kind of performance you are likely to see, you will see with Ceph, before you actually have to go out and buy the hardware. This is what is this? So this is a configuration that Intel presented at a database conference a couple of months ago. And this is an example, and there are other examples from other manufacturers. This is an example of an all NVMe PCIe cluster, and this one also was done with a new Ceph backend file system called BlueStore. So here there are 5 servers, and in each server there are 4 NVMe SSD, and because it's PCIe, we can point multiple Ceph OSDs at each NVMe device, which is what we did, and the performance is pretty good, right? So we got, you may not be able to, yeah, you can kind of see. So we got 1.6 million IOPS. We do look at the latencies in case you are very latency sensitive, and then we did not do too bad at write IOPS either. And so this is good and bad, right? The good here is we got about 80,000 IOPS per SSD on random read, and we got about 11,000 IOPS per SSD on write. So that is much, much better than hard disk, right? So for if you are interested in IOPS, this is much better. It's still it's still nowhere near the potential IOPS per SSD that these SSDs can do. So that's why Intel and others keep working on performance with Ceph to get the performance better. But this is quite respectable, and the same slide set that you can download also has sysbench numbers. So I did not have, I just wanted to show you an example, but it has the sysbench numbers. And then also something useful, even if you do not use all NVMe, this presentation also has all the Ceph tuning parameters that we used, because Ceph just, as you download it, its performance can be tuned a lot. Typically, you can get many times better Ceph performance by tuning a few things. And so those are our tuning parameters. Yeah, I guess I did. I did give you a little sysbench there, but the presentation has a lot of the sysbench numbers. So just a couple of slides more to mention. In addition to reference architectures, there are also OEM vendors, storage vendors that have Ceph appliances. And I just wanted to mention those, and this maybe is not a complete list, but I at least wanted you to be aware. Thomas Kran is a German storage OEM, and they have Ceph solutions that they make available. Right? Fujitsu is, you know, right, and this is a group in Germany that did this, but Fujitsu has a Ceph appliance for enterprises and some case studies. And I'm sure, and I think I mentioned them, but in the reference architectures, you did see examples from Supermicro, QCT, HPE, and certainly there are others like Dell and Cisco that offer, and probably many other that I'm not mentioning that offer Ceph hardware solutions. And many of them resell support if you want support, but because this is open source, many customers also support themselves with bug fixes or community support, and certainly that's a big advantage of open source. And I did not realize how strongly a case you made at Inktank that it will always be open source, right? So that was really fun to know. So here is just the summary for you of the reference architectures. If this slide set, I think, do we make the slides available or just the videos? Do you know? Slides available? Okay. So the slides that we will make available have the pointers. All of the reference architectures have the web pointers. I mean, you can search them all, but in case you have difficulty, the URL is there for all of these. But it's really good good things for Ceph. Thank you, and we have a few minutes if anyone has questions for me or for Patrick or for Leo. Yep. Yeah. Any questions? Okay, well, thank you very much for coming. I appreciate it, and listening to all this English. Thank you.